1 second, please. Okay. The one, if we can start here, we always represent the differentiation by d by dx, right? So if we are doing the differentiation of the trigonometric function like the sine x and cos x and the tangent x, so the differentiation of sine x is cos x, right?
Cos x.
Same way, if we do the differentiation of cos x, it will be
Negative sin x.
negative of sine x. Okay. Now, integration is opposite of the differentiation. Like if you do the differentiation of cos x, you get sine x, and if you do the differentiation of sine x, you get cos x. But if you just apply the opposite, then it will be like this. See how. If you do integration cos x, like if you apply integration part here, you will go back. Integration cos x, you will get sine x, and integration sine x will be negative of cos x.
Cos x.
That's fine. The same thing we go with the tangent as well. Like the differentiation of the tangent is the secant square x, and the same thing will happen here also. If you do the integration of the secant square x, then you will get the tangent x. And of course there is an integration constant because there is no definite integral, no limit is given here, so the integration constant will be added. Fine. If you do the integration of secant square x, the dx will always be there, then it will be the tangent x plus the integration constant. If you are given any integration limit like this, so now the integration is in the definite area or the definite curve, so the arbitrary integration constant will not appear, then you will not apply that. But yes, if it is an indefinite integral, there is no limit provided, that's in general integration. In that case, you have to put the integration constant. Clear?
Yes.
Same, if you do the differentiation for the cot x, it will be the minus of cosecant square x. And if you will go to the integration side, then you will do the integration of the cosecant square x, and you will get the answer as minus of cot of x, because the negative will go on there. We can't put the negative here in the integration part. The differentiation of the secant is secant x tangent x. And if you apply the integration, then integration of secant x and tan x is secant x plus c. The same with the cosecant also. The differentiation for the cosecant, remembering the formula for differentiation is easy. So
Yes.
the recommendation
Cosecant
is always just remember the formula
cot
for the
x.
differentiation, and then just do it like this,
Inverse.
inverse of that. So it will be like cosecant x and cot x. It will be giving you the minus
Negative.
of the cosecant x plus c. Something like this. Okay. There are some formula for the inverse also. Sine inverse, differentiation of sine in, because these things we will be using in the type 2 questions. If you have to do the differentiation of the sine inverse this function, it will be 1 upon this. Now in integration, sometimes you will see it will be directly like this, and there will be a formula for it, and when you will solve it, you will get it sine inverse. Okay, so
Yes.
you can just take a note of the differentiation one. So same if you do the integration for the the differentiation for the cos inverse of this function, it will be negative and the other thing will remain the same. If it is tangent inverse,
Yes.
then
1 by 1
tangent,
plus x square. I hope so.
it will be 1 upon 1 plus x square, and the root will not be there. Okay?
Yes.
And tangent and cot are inverse of each other, so if you take here cot, then it will be just negative, other things will remain same.
Yeah.
Right? And for the secant, like secant is the inverse of the cos, so if we take the secant inverse here, it will be the multiplied with this, multiplied with one more variable. Same if you do the cosecant x, again it will be multiplied with, but yeah, do remember that 1 minus x square and x square minus 1 is not the same thing, because here you see 1 minus
Yes.
x square and here it's x square minus 1, because we are not taking the modulus, right?
Yeah.
So that's it, one thing. Okay, hyperbolic function, we'll cover it later. For now, let's move on to the some questions and some formulas. If we do the differentiation of x square or x की power 4, we say it like differentiation of x raised to the
4x
power
cube.
nx and x n minus 1. So for x 4 minus 1 for x, right? So differentiation will
Yes.
be nx n minus 1.
1.
It will be the differentiation for x raised to the power n. Now what will be the
N.
differentiation for x raised to the power n plus 1? It will be n plus 1x. Right?
Yes.
So while we are doing the integration, we will be using both of them. Integration of x raised to the power n will be x raised to the power
X
n
power
plus 1 upon
n plus 1 by n plus 1.
n plus 1. And the indefinite integral is there, integration constant will come.
Let's see.
It becomes interesting when it comes to a raised to the power something, a raised to the power x something. So it will be a raised to the power x divided by the log of x.
Yeah.
Okay. Again, sin x minus cos, tangent x minus log cos x, you can say. Yeah, it is interesting. Sometimes if we do not have the basic information, in that case it confuses us. In some books you might see minus of log of cos of x, but the same thing can be written as the log of the secant of x. Right now,
Yes.
because the cos is equals to 1 by secant x, so we don't need to worry about that. So we can just replace it. Then we can say like here it's a negative here. Of course, minus of course will be the same. Then secant square x tan x, secant x tan x, secant x. Nothing much important after this. Better we go to the questions of the type 1 now. The questions that you have in your PDF, it was a type 8, that is integration by parts. Today itself we'll do that question also, because then you will feel, yeah, we have done something from your PDF as well. Okay.
Yes.
The very first thing is group 1, it says direct integration. We can just type 1. Whatever the formula we have done till now, we can apply the direct formula and can give the integration. Like if you have a question like this, let's say this is the question. So we can just write them like this. And just apply the formula of x raised to the power n. Right? Should we solve this, or should we move
Oh,
on?
it's all good. By part, yes.
Sure. No, you can just write the root x, you can cancel from here, then it will be x square root x over there, right? So
Yes.
like it will be like 3 minus 1 by 2. Again it's 1 minus 1 by 2 and it's already minus 1 by 2. So what it will come up here, it is 5 by 2, right?
Yes.
Yeah, 5 by 2 plus
Plus
1 by 2,
3x power 1 by 2.
and it's 4 minus 1 by 2. So
Yes.
it will be 5 by 2 plus 1, that is 7 by 2, and 3 will be as it is, x 1 by 2 plus 1, that is 3 by 2, and divide by 3 by 2, that is 2 by 3. Okay,
Yes.
and 4 minus of 1 by 2 plus 1 by 2, that is 1 by 2, and divide by minus 1 by 2, so it will be minus of 2 multiplied here, minus minus will it become plus, and it will be root of x in the plus, and no dx will be there, plus integration also. So here we are not using any substitution, we are not using any trigonometric function, we directly applied the formula that we have done, right? Let's
Yes.
try some simple questions. Never try to avoid the simple question in integration. What student usually do, because if we remember the formula, we can easily do the questions with the formula, everyone knows that. But integration is kind of things now, if you keep going closer to the integration, you will feel it's difficult. So if you want to do the practice, never take a difficult question of integration, always try to solve the easiest one. There you will gain the confidence, and once you have the confidence, you can easily tackle the problem with the higher complication things. Because in the complicated things also, you have to do the substitution of the simple formulas. So if you are comfortable with the simple formulas, then only then you will be able to tackle the questions with the substitution part. Okay, if you can try this, just open the bracket, it will be the cosecant square x, and it will be cosecant x cot x, and then the cosecant square x, the formula was minus of cot x, and cosecant x cot x was the formula of the cosecant x. So what's the answer?
Cosecant.
Take it.
Cosecant square x plus
Cosecant square
cosecant
x
x
will
cot
be
x.
cot x, and cosecant,
Cosecant
x
x
cot
cot
x
x.
will be minus of the cosecant x, because minus cosecant x differentiation is cosecant x cot x, right? Yeah.
Yes.
So what the answer?
Yeah, minus cot x
Mhm.
minus cosecant x plus c.
Minus cot x minus cosecant x plus c. Okay. Okay. 2 minus 3 sin x upon cos square x. 2 minus 3 sin x divided by cos square x into dx.
Two will be outside as 2 is a
Yes.
constant.
Yes.
No.
We can take
Yes,
it out.
okay.
Like first you have to just separate them, like 2 by cos square x, then this, and then you can apply this.
Yes. Integral of 2 by cos x cos square x minus 3 by sin x by cosecant square x.
Minus 3 sin upon cos square.
Cosecant.
Then
We have to outside as a constant, and then 1 by cos square x, that is
so we can
that
take
is
2 like this.
secant square x
It will be the secant square x dx, and the same way here it will be
minus 3
3.
outside, that is sin square x sin x. So
Yeah.
sin x by cos x or cos x.
Yes.
So we can take it sin x by cos x, that is tan
tan
x,
x, right?
into
Mm-hmm.
that is sin x by
It's like sin x divided by cos into cos, so it becomes 10 by cos,
1 by
and that
yes,
it you
1
can
by
like secant,
cos x secant
right?
secant x
Then tan x secant x is formula of
minus
differentiation of
minus
secant x. Yes, yes.
cosecant
like differentiation of the secant was the tangent x secant x. So integration of tangent x secant x, it will be the secant x, and secant square x,
Yes.
tan x.
Cosec tan
That
x.
is it.
Yeah.
Okay.
Yes.
Okay, let's try this one.
Can be written in x to the power half, that is x power n,
Yes.
the root x, so half x power minus 1 by 2.
Mm-hmm.
We are doing an integration, right?
Yes,
So
integration.
x power 1 by 2 plus 1 by 1 by 2 plus 1, x power n,
Hmm.
that is x power 1 by 2. So x power 1 by 2 plus 1 by 1 by 2
Like
plus
it will
1.
be like a minus b whole square, right?
Yes, a minus b square.
So it will be a square plus b square minus 2ab, and then by applying the formula
Plus b
we can
square.
easily solve that. So I just write some, it was the type 1 where you can easily apply the formula directly and do the question. So I just write few of the practice questions here. This was the first one, and if you can try, because it is a raised to the power x, so this one will be applied here. This thing you can just write it like this, right? Something like this,
Yes.
and then it just integrate it, differentiate. That's how it will become the easy. Now we comes to the important part of the integration, where one more thing, if we are moving to type 2, then type 1 will be used in this calculation of the type 2. If we are going to the type 3, then type 1 and 2 both will be used while we doing the calculation for the type 3. So it is scheduled something like that. So it is the like general substitution. Or you can say like the denominator substitution. We directly substitute the denominator is equals to t. Let's say if someone asks you to integrate tangent x, we do not have the formula for the tangent x. We had the formula for the secant square x, which was the tangent x. So in that case, we just try to do it in sin x divided by cos x. Now we have a formula for sin x, but we do not have the formula for sin x into secant x, right? It was secant x tan x.
Yes.
Now in that case, what we do, we just put the denominator equals to any variable, let's say it's t. So here it becomes like cos of x is t. Now you also have to replace the d of x. Now if you find out d of t here, what will be the differentiation of the cos of x with respect to t? Cos x is minus of sin x and dx.
Yes.
So minus of sin x dx is dt. So you see here sin x dx. In place of this sin x dx, you can put dt. So it will become minus of dt divided by t. Now the integration is very easy. Negative you can just take it out, and it will be dt divided by t, which is log of t plus c. Now put the value of t. What happened? I think my stop share happens. Okay, let me just open
I
the
guess your
notebook again.
screen has stopped.
Yeah, sometimes it happens that one note automatically
Is it
stops
some
working.
network connection?
I'm just starting it again.
Sure. Ah, yes. As a glitch. Yeah.
Okay, let's try this now. Sharing the screen again.